Hello everyone, let us solve this question. Here we are given that there is an electric dipole consisting of two charges of magnitudes minus q and plus q separated by a distance d. Initially it is in this orientation. It is said that the dipole moment is pointing along I cap. At t equal to 0, electric field E j cap is switched on and then it is switched off at time t equal to tf. Then we have to check four options. Option A is the center of mass of the dipole is deflected towards j cap in the presence of the field. So the electric field will apply force in downward direction on QE and upward direction on this. Here the force will be QE downwards and here the force will be QE upwards. So the net force is 0. So the center of mass will not move. The center of mass will stay exactly here. It will not deflect towards j cap. So option A is incorrect. Option B is if the magnitude of the final angular velocity omega f is under root 2 QE by md, then it implies that theta f is pi by 6. This is option B. So let's check it. While it will rotate, the torque about the center of the electric field will change continuously. So when it has rotated through an angle theta, it would be in such an orientation. This distance is d. The force here is QE upwards and here it's QE downwards. Torque about the center of this force QE will be QE times this distance. This is b by 2 cos theta. The torque is in counterclockwise direction. The torque due to this force QE about the center of mass would be QE times this distance, which is b by 2 cos theta. In this sense, so they both are in the same sense. So plus QE d by 2 cos theta. So this would be QE d cos theta. This is the torque as a function of theta when it has rotated through angle theta. Now we know that tau equal to I alpha. The moment of inertia of this system about the center of mass is, so the moment of inertia of this about the center of mass would be m into distance square, so m into d by 2 square, and same for this, so twice of this, that is m d square by 2. This is the moment of inertia. Applying tau equal to I alpha, QE d cos theta equals md square by 2 alpha. D is cancelled, so 2 QE by md cos theta equals alpha. We know that just like A equals V dV by dx, similarly alpha equals omega d omega over d theta. So alpha is omega d omega by d theta. Integrating, initially the angular velocity was 0, finally let us say it is omega. Initially the angle was 0 and finally it is theta. 2 QE by md sin theta, integration of cos theta d theta sin theta from 0 to theta, so sin theta equals omega square by 2. So omega square equals 4 QE by md sin theta. In the option B, it is said that if omega f is this, then theta f is this. Substituting this omega f here, omega square will be 2 QE by md equals 4QE by MD sine theta F, the final angle. So sine theta F is half, theta F is sine inverse half, that is 30 degree or pi by 6 radians. So option B is correct. Option C is, if theta F is pi by 3, then the change in kinetic energy of the dipole is given by 2 root 3 QED. Option C is, if theta F is pi by 3, then change in kinetic energy of dipole is 2 root 3 QED. Let us check it. Change in kinetic energy is final kinetic energy minus initial kinetic energy. Initially it was at rest, so initial kinetic energy is 0. So change in kinetic energy is just the final kinetic energy. Since it is just rotating and not translating, final kinetic energy would be half I omega square, half I, moment of inertia was md square by 4 plus md square by 4. So md square by 2, omega square. If theta F is pi by 3, then what would be omega? I erased it. So, what was it? I think omega square equals 2QE by MD sine theta. 4QE by MD sine theta. And because if we put omega F equal to this, we will get theta equal to 30 degree. So omega square equal to 4QE by MD sine theta. So omega square, if theta final is pi by 3, if this is pi by 3, sine pi by 3, root 3 by 2. So 2QE by MD root 3. Substituting omega square here, 2QE root 3 by MD, MD. So root 3 QED by 2. This will be the change in kinetic energy. But it is said it is 2 root 3 QED. It is root 3 QED by 2. So option C is incorrect. Option D. For theta F equal to pi by 4, the dipole rotates around its center of mass with constant angular velocity after t greater than Tf. So t equal to Tf is the time when this electric field is switched off. So after this time, it is said if theta F is pi by 4, then it will rotate with constant angular velocity. So yes, this option is correct, because once the electric field is switched off, the net force on this is 0, the net torque is also 0. So with whatever angular velocity it would have attained by that time, when theta was pi by 4, it will continue to rotate with that angular velocity due to its inertia. So for any angle this would be true. So for this angle also it is true. So this option is correct. And correct answers are B and D.